Hi everyone, today I'm going to talk about this question, k smallest number in a sorted matrix. So the matrix means a 2D int array. We can clarify this question with input and output. So the input going to be a 2D int array, we call it the matrix, and the output is an integer. So the output going to be the k smallest number in this matrix, okay? So we can also do some assumption as well. The k is bigger than 0 and smaller than n times n, m. The m is a row number, the m is a column number. So n times m is how many elements in this matrix. We can assume the row number is bigger than 0 and the column number is bigger than 0 as well. Today I'm going to use a BFS2 best first search way to solve this question. And to do that, I want to build up a data structure class, which I call it cell. This cell class is going to have a row integer, row index and column index and a integer value. I'm going to build it later. And in this method, BFS2 method, I'm going to maintain a priority queue, which I call it a min heap, and put the cells into it. So the cells has a smaller number, has the higher priority. And what I'm going to do here is I'm going to pull out, or let's say expand it, the min heap for k minus 1 times. So after k minus 1 times operation, the answer going to be in the top of this min heap. And then I just need to pick it and get the value and return the value. Cool. So for the time and the space complexity of this question, like we see, we have a min heap in here, and the min heap gonna store like k cells in the min heap, and for each cell, I would do the operation offer for one time and generate two vertex in the horizontal way and the vertical way. So it's gonna be 3 log k times k nodes to do the same operation in total. So the time complexity gonna be k log k in total. And the space complexity, it comes from stack and also heap. So for the method itself, in stack it costs 1 time. But for the heap, there are a extra space that we use for the min heap, and we know the size of the min heap gonna be k. So the time complexity in total gonna be OK. Cool. Next, let's write the code about this question. So before we write the method, we want to build this self-defined class, like we said, it's cell that stores the row index and column index and the value. So I set it as integer row, integer x, integer y, and integer value. When I need to new a object, I'm gonna need to use all the input. ALUA. Okay. Okay, so in here, the input x gonna be the x, the input y gonna be y, input value gonna be value. Okay, this is a self-defined class. Now we can write the code. So the output type gonna be an integer, and we're gonna name it as smaller. Just case, that's fine. And the input is a matrix. Okay. So let's get in here. And a few data structures we need to maintain for this question. So we got the min heap, and I also need to maintain a data structure that stores all the nodes that we have been visited before, so we can use it for duplication purpose, which I'm going to use a Boolean array. But first of all, let's get the row number of this input matrix, which is matrix.length, and the column number, which is matrix first element dot length. And now we can build up this Boolean matrix, which is the same size as input matrix. We call it visited. If the vertex is visited before, we're going to mark it as true. So same size row, same size column. Okay. And then another data structure we need is a priority queue, which stores cell. We call it min heap and a new priority queue. So let's say initialize with k, size k, and we need to new a comparator, which I want to compare. How do we want to do with the cell? So in here, I'm going to need to overwrite a function. Overwrite a function. Okay. It's called compare. So what I'm going to do is compare the priority of two objects. If I have object O1 a cell and O2 a cell, and they have the same value, so O1 dot value equals to O2 dot value, just return 0, which means they have the same priority. Or I can return O1 dot value is smaller than O2 dot value. I can return -1 for that case, otherwise it's going to be 1. So which means the smaller value has the higher priority. Okay. And we finished the min heap implementation. Now offer something into the min heap, which we know it has to be a cell. So we new cell start with 0 row, 0 column, and the value of this position. Okay, and we want to mark visited. We want to mark this position as true. Okay. Now we need to do k-1 times operation to get the last cell we want. So for k-1, this is k-1 times. What we want to do here is operate the cell. So firstly, we got a cell cur equals to min heap dot put it out, and there are some information we need to see. So if the cur dot x, which is the row number for the cell, can be expanded, which is +1 still smaller than the input row number, and this node wasn't visited before. So check Boolean array cur.x +1 and cur.y. The same position is not visited before. If that's so, we can offer this node into the min heap. So new cell cur.x +1 cur.y, and matrix of this position cur.x +1 cur.y. Don't forget to mark visited, mark the same position as true. Cur.x +1 cur.y. Yep. Same for the horizontal directions. I'm just gonna copy the whole vertical, the horizontal into vertical. So in vertical, it's gonna be y minus 1, and we want to make sure y minus 1 is inside the range, and the mean hip over the horizontal position plus 1 here plus 1, and we mark same place as 2. Okay, we got horizontal position expanded, generated one vertex from horizontal position and generated a vertex from the vertical position. Okay, now out of the for loop, we have done this k minus 1 times out of the for loop, we can just return. So the mean hip dot pick is what we want, but it's a cell, so we dot value. That's exactly what we want for this question. Thank you everybody for listening, and let me know if you have any question. I see you next time. Bye-bye.